All right, this is part 2 for Module 9, Lesson 1. I'm on page 407, and I'm looking at example 2. So it says to solve the special system of equations by graphing and identify the system. All right, so we have this system of linear equations, and I'm going to take each equation, and remember, I can put 0 in for y to get the x-intercept. I can put 0 in for x to get the y-intercept. So remember, this is like 1 comma 0 if you wanted an ordered pair. This is 0 comma negative 2, etc. Okay, I'm not even going to worry with the third point. But I am going to show you this. So this is the format of the first equation. Here's the format of the second equation. But if I take that second equation and solve it for y, I get this. And what I'm hoping that you will see is when you put it in slope-intercept form, which is this format, you see that this line has the same slope as this line. So same slope, different y-intercept, but if they have the same slope, those two lines are parallel, and parallel lines are never going to cross. Okay? So for instance, in this particular situation, there is no solution. There is no ordered pair that when I put it into both of these equations, it will make both of the equations true. Okay? No solution. Okay? Since there are no solutions, this is an inconsistent system. Remember the little graphic organizer that I put on page 404 about systems. All right, let's look at B. We have y equals 3x minus 3, and then our second line is negative 3x plus y equals negative 3. All right, so this one's in slope-intercept form. Great. Figure out your x and your y-intercept. This one is in standard form, but I'm going to put it into slope-intercept form by moving the 3x, by adding it to both sides. And when I do that, I get y equals 3x minus 3. So that's my red line. My blue line is also y equals 3x minus 3. So guess what? They're really the same line. Okay? Find the point of intersection. Well, since they're really the same line, come down here. The two lines coincide, so there are an infinite number of solutions. There are infinite solutions. They have the same slope and the same y-intercept. Therefore, they are the same lines. This is A, all right, and go back to your notes. I didn't even fill it in on y'all's. If you have an infinite number of solutions, this is a consistent dependent system, okay? So that's what goes down there. This is a consistent and dependent system. All right, I am now on page 408, and we're going to do one of these on the graphing calculator, just so that you can see that, yes, we have a way of, you can do it by hand, certainly. You can just graph everything like we've been doing, but you can also do this on your TI-83. All right, so here's an example. We have these two equations, and it says to graph the equations using a graphing calculator. They simplified it like this, and that's fine. It looks a little bit different than your garden variety slope-intercept form, but that's basically what it is. So this equation, what they did is they moved the x over, and then they divided everything by negative 3. Okay, and you're basically going to get 1/3 x minus 1 is the equation for this one. Okay, so we're going to go over here to y equals. And because the fraction we need to make sure that the x is not in the denominator of the fraction. We're going to put the fraction in parentheses. 1/3 x minus 1. You're like, Miss Goff, it looks different. Well, remember, negative x divided by 3 is 1/3 x. And 3 divided by negative 3 is negative 1. So that's basically, it's this equation. It's just I formatted it a little bit differently. Okay, and then my second equation, let's see, is basically you're taking this, move the 5x over here, so you have 10 plus 5x, or 5x plus 10, whichever. And then when you take 5x and divide it by 2, that's 2.5x. And when you say 10 divided by 2, that is a positive 5. So there are your two lines. Okay. Again, they look a little bit different than what they have, but if you type it in the way that they have it typed in, that's fine. Just make sure you put parentheses when parentheses are given, because they're important. Your window settings should be good with default window settings. Go to graph. So there's your first line. There's your second line. And we can see that this intersection is the solution, but I don't exactly know what precisely that point is. So there's a way that you can figure it out. So hit the second function button and then go to trace, because you're going to pull up this calc menu. So second trace, here's your calculate. We want the intersection. We want to know where do those two lines intersect. So we say 5. And I have still I've yet to understand why they do this little guessing game, but anyway, just, all right, first curve. They're basically showing you that's the y-intercept of the first line. Just hit enter. There's the y-intercept of the second line. Again, I don't know why they do that. Just hit enter again. Guess? Yes, take a guess. Tell me where they intersect, because they're going to tell you this little intersection point. So just hit enter again. Does a little calculation. All right, so these two lines intersect at x equals negative 2.769, whatever, y equals negative 1.923, blah, blah, blah. Okay, so the two lines appear to intersect at about negative 2.8, negative 1.9. Okay, so that is how you can do this on a calculator. All right, let's hop down to B. We're going to do basically the same thing. We're just going to practice, do another one. I have these two lines, 6 minus 2y equals 3x. Where am I? They're right there. And we have y is equal to 4x plus 8. So this one's already in slope-intercept form, so I'm just going to leave that alone. But this other one, I'm going to do a little rearranging. First, I moved the 6 over. Then I divided everything by negative 2. And when I do that, this is the same line, but in slope-intercept form. So I have y equals negative 1.5x plus 3. And then I have this other equation. So here are my two equations, here and here. Okay? All right, so let me get my calculator over here where it's handy. I'm going to clear this, go back to this, clear all this. Clear. All right, because I need to write these other equations. All right, so this one's a little bit cut off. Y is equal to 4x plus 8. Come on, back up there. 4x plus 8. The other one is negative 1.5x plus 3. Go to graph. Right? And that's what you get this time. And you could do this by hand over here, but I'm not going to. Okay? All right. So again, I want to know where they intersect. So go to second. We're going to have the calculator menu. So second trace. I want the 5. I want an intersection. Again, they love to show you, here's the first curve, y-intercept. Second curve, it's y-intercept. Do you want to take a guess? Yes, I do. And then it'll, for some reason, decide to show you the intersection point, which is right there. Okay, so this solution is negative, basically 0.91. X is negative 0.91. Y is 4.36, basically. Okay, so your solution is negative 0.91, comma, 4.36 repeating. Okay. That's the approximate solution. So for instance, you would put it right there. And if you graphed it by hand over here, this is basically what you would get. Okay, so you can do it by hand, which I recommend because that's good practice, or you can do it on the calculator.